Yeah, so good morning, everyone. My name is Albert. I'm from the Yahoo Paranoid team, which our team work for security engineering and doing reviews and consultation for the whole company. And today we also have my colleague, Nera, who is also part of the Yahoo Paranoid team. And here we are going to talk about a new solution that we have to detect DOM XSS issue. So before we start, just a little bit introduction. There are a lot of people who always think about what security folks in company they look like. Some people say they are more like hacker. They try to break some of the stuff. And I actually like the way that if there is a profession like a doctor that they can cure some problem for the computer, that I would like to be that guy. But what actually happened is that I'm just a software programmer like anyone else. I look at the computer every day, lots of headaches, seeing all the problem. But in general, it looks like we are more like work on all three aspects of that. We break some stuff, we try to prevent some stuff, and we also develop things. So for today, we try to present our solution for DOM XSS. So we are going to talk about what is DOM XSS, the solution of that, how our solution works. And in the end, we are also going to show you guys a demo that looks pretty cool in my view. So what is DOM XSS? If that's very simple, we can explain that in one picture that's more like that. Use something execute in the DOM. But in reality, this is actually not something new. It was first discussed in year 2005 that one of the pioneers, he submitted an article to the W3 community talking about there is a way that you can exploit the XSS problem without having the payload going into the server-side logic. That means if you look at the example here, the payload itself is just it extracts from the URL, and then the client-side JavaScript try to analyze, try to process the data and make it execute in the browser. So in that case, if you have some malicious payload on the URL, then the attacker can steal your data inside the DOM, which is the object inside the browser that store all the credentials. So if this is not a new problem, why we are so interested on that? The fact is that DOM XSS has some very interesting properties. So if you look at how it works, you can see that the payload itself can actually bypass the server-side detection. That means if I put a payload on a URL hash, or if the payload is getting fooled by some user interaction, it doesn't go to the server, right? So if you try to look at the SS log, or you try to install some application firewall, you will never be able to detect DOM XSS, right? And also there's some other pioneer like Google, Facebook, they propose some server-side framework to defeat XSS, like Google Kosher or Facebook Hip Hop, right? But if you look at that, they can only prevent XSS from happening on the server side. You'd never be able to look at the client-side logic, right? So this actually creates lots of opportunities for bug bounty hunter, right? Because if I want to get the reward and I want to bypass your protection, I just want to look at the things that you cannot protect. So that becomes a more and more interesting problem for the security folks in the industry. So what is the way that we can detect DOM XSS? Most people will look at static analysis. And I also try to explain why static analysis doesn't work in that sense. So maybe I could use a very simple example how static analysis works. In reality, if I try to think in the way that the DOM, the browser, is a living creature, then if you need to do static analysis, it's just like you are trying to cut it open, look at how things work inside, seeing all the blood vessel, the muscle, and skeleton. But because you actually cut it open, it doesn't have any dynamic workflow there. That means you need to imagine by yourself how everything sticks together. So in reality, in the web environment, when DOM XSS happened, it happened in the JavaScript space, right? JavaScript context. So here you can see all the JavaScript in a real environment. The left-hand side is Yahoo, the right-hand side is Google. So it's actually very, very complex if you need to analyze that. And even more than that, there are more static components that can be injected into a browser, like you can actually hook some anonymous function on JavaScript that actually get more JavaScript in place. And also there are some strip source tag that you can inject some third-party JavaScript there. So it's very difficult to collect all the JavaScript. And what's more is that there are also dynamic logic to add JavaScript. Like you can actually create strip inside a strip. Like here you can see I can do a document.create element that actually inject more strip. And sometimes you can also cache some user action when I click a link. You actually execute some other JavaScript. So in summary, for static analysis, it's generally very hard because you need to get all the snapshots, and also there are some dynamic logic inside, right? And further, if you think about JavaScript alone, that may be easy, but there are also HTML, JavaScript, CSS. In combination of all of them, if you need to do a static analysis, it's just like you need to do an analysis on C program together with Java, right? So it's actually a very hard problem. So today we are going to talk about our solution that works in a different way. So I will pass on to my colleague Nera to talk about that.
Thank you, Albert. The next session is going to discuss about how we solve the problem. I guess everybody right now here understands static analysis is kind of hard. If you are a programmer, it is just code review. You need to review everything, and then to understand what is actually inside, and then how's the workflow. So our approach here today is another direction. We call the dynamic approach of the tainted analysis. In order to make you more understanding, I use the same metaphor that the web application is just the living creatures. We want to understand the blood, how the blood flow within your body, from which organs to another one, and then all those stuff. And then the idea is we will try to inject some tracking agent into your blood, and then to observe how the agent passing through your blood or within your body. So this is the ideas. And then in terms of the programming, what the block is actually the string. Because when you are building web application, all those programming is actually talking about the character, the string. And then our idea is to add the tracking agent on the string. We call it the tainted thread. And then during the execution of a JavaScript, we will propagate that tracking agent during all the arithmetic operation of a string, like assignment, like concap, all those stuff. This is the ideas. In order to achieve this, we have did something. Firstly, we need to pick up some browser-like tools. One of the candidates fit our need is PhantomJS. I'm not quite sure whether everybody know it. The PhantomJS is a headless browser. It is actually run on top of the JavaScript coil engine and the WebKit engine. And then the headless means that you can run on the command line. And then it is just the same as the real browser, but without the GUI, without the UI. So that is the first thing why we pick up the PhantomJS to do it. And then another things we do is we hack the JavaScript coil engine by adding the taint signal into it. During the JavaScript coil engine execute the JavaScript, we will propagate that tracking agent we call the tainted thread through all the arithmetic operations. And then the third thing we are doing, we will look into the DOM. For DOM, everybody is a document object model. There is an input, we call the source, and then there is an output, we call the sink. For the source, everybody know maybe the one typical example is a URL. It's actually you can input everything into the URL. And then for the output, the sink, actually the typical example is a document.write, when you can write something back to the DOM. So here is some example what we have hacked into the JavaScript coil engine. On top, you can see a free line of a very simple JavaScript. The first line is we read something from the source, and then the second is we do some string operation, and then finally it's a sync. So in the first line, we hack something when the browser call the source. We will add that signal into it, and then assign a unique number. We will call it tainted signal, and then that identifier we will regard as a flow, one of the execution flow of your string. And then second, we will it's just a very simple substring operation. When you call the substring function, we will detect whether that tainted signal are within the string. If it is yes, and then we will return back. If it is not, we just leave it alone. And then finally, we will detect whether that signal is actually happen at the sink of the DOM. And then if it is the case, we will flag true that something passed through. If it is not, just leave it alone. And then we will try to scan all the web application through this kind of a mechanism and then report back that whether your DOM is tainted or not. But it doesn't mean it's work because when you imagine the web application, right now, no matter how complicated it is, we emulate the same behavior of the execution of a JavaScript when you load it. So no matter how complicated it is, we can still analyze it. So our scanner, there's some two findings in our scanner. I use the same JavaScript. You can see the free line of the JavaScript. And then when you are seeing this, you can see when we visit that pieces of the JavaScript hosting by a server, we find two findings. One finding is you can see the source. We assign free unit number over there. We identify their free execution flow for the JavaScript. And then you can see if you look into the number 2, actually you can see the number 2 has executed the substring operation. And then finally, we can detect that tainted signal at the output of the DOM, which is what we are expected. And then the second thing is we identify the browser actually has a hidden flow. When you look into the code, you can never find it. We never know that execution flow, but our dynamic approach can identify there is one of the flow is the location half is being coded and then being executed by some of the string operation, but okay, it never happened at the same, but we identify a hidden flow within it. So this is the two finding by our dynamic scanner. So in order to make our tools more usable, what I mentioned is we identify the document string, but it doesn't mean it's a DOM XSS vulnerable. But that signal allow us to fuzz the input because we know something passed through, and then we will inject some vulnerable pattern into the input and then try to detect it. So because we rely on the PhantomJS, there is an alert handler. If there is something pop up, we are sure that it's a DOM XSS vulnerable, so we will try to fuzz the input. And then there are some well-known pattern if you're a hacker to hack the DOM XSS, so you will know what pattern to inject in to fuzz it. And then if combining the tainted signal and the own alert signal, if both of the conditions are true, and then we will tell you that your web application is DOM XSS vulnerable. So our goal, why we are doing this, because we want to achieve the zero false alarm of our scanner means that we can actually tell you that your web application is vulnerable when we scan it. This is very important because you have a false alarm and then your tools is not usable. So that is our goal to make our scanner a usable security tools. So another things that we have done is we try to benchmark the penalty hit by adding that tainted propagations logic within. For the memory usage, we find the performance hit is negligible. The average memory usage, we run 10 times the same URL, same application, same logic. We find the memory usage actually is, the difference is very negligible. It is also, the same conclusion can come from the network latency because actually the round trip time dominate the performance, and then our logic within the JavaScript call engine doesn't hurt too much. So let me do a quick demo to our tools. Firstly, we have actually find some of the web application on the web, and then we find that there right now out there are many JavaScript framework, and then which is very popular to help you to make some very cool web applications. So that's why we find this website. There are around 60 different type of framework, and then we scan all those, and then we find 4 of them are actually DOM XSS swallowable. And then one of them is this one. This is very simple to do application, and then you can input the task, and then you can see the to-do list. And then we try to input some of a well-known attack vector, and then you can see I can trigger the execute of the JavaScript, and then it is a DOM XSS swallowable application. In our scanner, okay. So in our scanner, we also try to run the same URL, and then this is the same URL of the web application. And then we will scan through it. And then you can see we can trigger an alert signal, and then also identify a lot of different the JavaScript execution flow. You can see there is a lot, even though you just simply input the text into the text bar, and then actually there are around 50-something execution within. You never know it when you're doing the static analysis, but we identify it. And then for one of the input, we add the signal called in order to make it more easy to identify, we add a signal called the 9999, which is the input user interaction we are input, just like I do it the same in the web application. And then we can identify that signal being propagated somewhere, and I score it. No propagation. It is actually directly to the sink. So by combining these 2 signals, we can tell you that your application is swallowable, DOM XSS swallowable. So, and then on top of a PhantomJS, because there are a lot of different user interaction, as a QA engineer, you can cook all the interaction into the Tainted PhantomJS, our scanner, and then you can detect it. So it is kind of flexible. So let me give you a quick summary of our work. Firstly, we are going to open source our scanner. So we are the first one to have a DOM XSS scanner in the marketplace. And then because our approach is this kind of a dynamic approach, so we circumvent the static analysis problem for DOM XSS detection. And then our solution right now is robust because we didn't find any great performance hit on the memory usage, network latency, so it is robust. And then we are actually based on the WebKit. It is not the emulation. It is the same as the user interaction on the browser, just without the GUI. And then it is a command line tool, so that's why you can easily integrate it with all the automation tasks. And then finally, because we rely on the alert handler being called, so our scanner can report us have achieved the zero false alarm alarm of our detection. So it is usable for DOM XSS detection. Yeah, and then if you want to know further, because it's a kind of a very hacky way to hack the JavaScript code. The code is ugly, and then if anybody like to refactor it, we are welcome, because we just want to prove our concept is more good, better than the static analysis, and so that's why you can find more information in the GitHub, and then stay tuned. There are some creative being used and the license, and then we would like to thank some folk within Yahoo also, like Bishan, Dimitri, Prison, Dewayne, and Christopher, and of course Yahoo to give us the opportunity to present here, because they have contributed some of their ideas and work with our project. Yeah. So yeah, that's it for my work today. And then Albert, do you have?
Yeah, so we actually have the demo on the YouTube channel, so you can go to YouTube and yeah, because actually we try very hard to connect to the internet, but we cannot connect that. So there's the demo itself. If you want to see that again, you can go to YouTube. And thanks very much for coming. And any questions so far? Yeah. So we claim that we are the first on doing tainted analysis, on doing open sourcing a tainted analysis, right? So Dominator works in a very, very cool way. So thanks for the question. So Dominator, how it works is they actually try to modify Firefox, and then they try to solve the problem on collecting all the JavaScript, as I mentioned, right? And then from there, they want to do a static analysis and see how things work from there. So yeah, I would say there's some difference, but I think I need to double check. But I would believe they are more towards doing static analysis because I see that they try to do I forget it's SpyMonkey or is it SPime, something like that. They try to do the analysis on the JavaScript they collected and then output the finding on the console, right? So yeah, I think we should double check. Yeah, I actually purchased one of that. I actually purchased one of that. Yeah, this morning we also have some communication with him on. He said Tainted will be interesting. It will be an interesting work, but I think I need to double check how he's working on the Tainted part. Because my early understanding, last time I checked, they're doing static analysis, but you may be right. They may be doing some other things as well.
Okay, for the zero false alarm, I mean that approach, we need to know some known pattern for the injection. So because how we do that? Because first thing we detect that document is dominated, and then if it is tainted, and then we will do the first input operation to improve our scanning efficiency, and then when we are first to input, we need to have some pattern, and then some of the pattern is very well known for the DOM XSS. So we will try this different input. If we can trigger on alert, and then we will report it is a zero false. It's confirmed vulnerable attack. So in this path, there is a chance we miss some pattern, of course, because if there's somebody know, oh, that pattern can inject, and then our scanner may not scan that pattern. But if we identify that pattern, we will continue to add back to our database to have that pattern for scanning next time. So this is the way we want to make our tools to more usable, because there is a trace-off is for the zero false alarm is we cannot make sure cover all the pattern, but we contribute from time to time because we know some new pattern, and then we add it into it, and then continues to contribute back to our database of it. Yeah, I agree to your point, but there is something right now in our mind is, for example, you write a web application, you need to do the QA test, okay? It is a must, okay. How do you do it? Maybe you script the user interaction, and then if you write on the PhantomJS to do that kind of automation test, and then we will empower you to report back that whether your application is DOM XSS vulnerable or not. That is one thing, because you just add a field line to check the condition whether the document is tainted or not. And then the second thing is you are talking about another great challenge is there are a lot of different user interaction. You need to understand the context. For example, you need to know to click that button and then to do that, and then you complete the flow. But our thinking is in the QA automation test or QA test, you already cover. So I doesn't care about that part because you cover it and then just enable it to tell whether it's tainted or not. So that is our ideas and then the direction to tackle that problem. But if you are talking about more another challenge is to understanding the context of the web application. We are trying to explore it. Maybe some guys say it is an AI or whatever, but yeah, it's an open question on that part. If we can solve it, it is scary, it's terrible because we can scan all the stuff on the internet.
So just adding on that, I think one of the challenge of doing static analysis. For the fact that I've tried evaluate a lot of commercial analyzer, they claim that they can do that, right? But the fact is, what they would try to take as an input, they will ask you to provide the JavaScript instead of the HTML. So from there, that is already a huge limitation because all the web page they are built from HTML. Not to mention that they cannot handle event handler, those things, right? So I would say generally there are harder limitation on doing static analysis as compared with dynamic one, and then from there we try to look at how we should do dynamic analysis in a more effective way, so such that we try to do tainted analysis, and then we can figure out all those things flowing through in a more efficient way, rather than fussing through all the things. I think that's kind of the direction that we are trying to work on.
For the first question is how can I identify all the sync, right? Source and sync is actually based on the DOM specification. For example, the source means that for all the input that can be modified by the user, and then we will claim it is a source because we can input some untrusted data over there. And then for the sync, also all those function on the DOM that can echo the output, and then we will classify it as a sync. So that is we actually based on the DOM specification. And then the second question is okay, for the exploit, because we will try to fuzz the input if it is tainted for some well-known pattern, and then we actually have a database collecting all those patterns. So we will try to use that pattern to inject into our scanner, and then to try to execute it. If it is it can be executed, and then we will claim it is DOM XSS vulnerable. Maybe we can talk offline because it seems like we are running out of time, right? Oh, okay. Sorry. Thank you.